Hi guys, welcome back. We're starting chapter 14 today. We're actually going to cover both section 1 and 2. We jumped ahead in the book a little bit, don't worry. Just make sure you're following along in the book and taking notes as we go, because your tests will be on these lectures, okay? Alright, so we're talking all about the atmosphere now. We're moving from the water on the earth to partly the water around the earth, but mainly all of the gases around the earth, okay? So by definition, the atmosphere is that layer of gases surrounding the earth, and it's not just oxygen. There's a lot more to it, but we'll get there. To kind of give you an idea of scale, the atmosphere is roughly 3,000 miles thick. So if you start at the surface of the earth, the atmosphere goes about 300 miles above the surface, but there's not a clear limit to it. The gas particles kind of get less dense as it goes, and it simply fades away, and then all of a sudden you're in space. The majority of those gas particles are within 10 miles of the surface, so it gets thinner and thinner and less dense as it goes. Okay, 300 miles is kind of hard to visualize. The diameter of the Earth itself is close to 8,000 miles, so it's not very thick compared to the Earth. The book gives you a really kind of fun analogy, a fun illustration to think of. If you took an apple and you breathed on the apple and you went on the apple, the fine layer of moisture on the apple would be the atmosphere. Okay, so really thin compared to the Earth itself. Weather occurs in the atmosphere. So we've talked about climate before. Climate is kind of the average conditions and what happens during seasons and different locations. Weather is what's happening right at that moment at a specific place. So when you look at your weather app on your phones, it's telling you what's going to be happening where you are, and that occurs in the atmosphere. All right, so why is the sky blue? One of the biggest questions I get, one of the number one questions online, it's complicated, and it has nothing to do with the oceans, okay? So as the light from the sun is coming in through the atmosphere, it's kind of being interfered with, okay? So as the light's going through space, there's nothing for it to bounce off of. And that's why when you're in outer space, it's black. There's still the sun's energy getting there, but you don't really perceive the light because there's nothing for it to bounce off of, all right? The sunlight comes to us in all the colors of the rainbow. And when it hits the atmosphere, it kind of starts bouncing around, and it breaks up into that spectrum. If the sun is right overhead, we perceive that sunlight as a white light because we're getting all of the visible spectrum there. But the blue light, a little bit of the purple light, a little bit of the green light, those get scattered the most by the particles of gas in the atmosphere. And so when we look at the sky itself, we see that spectrum of light kind of getting stuck somewhat. They're just bouncing around more, and so it looks blue, okay? Let me grab my pen for a second here. That's what's happening here, okay? So that would be kind of at noon. That would be in the middle of the day or in the afternoon. Up here, that's kind of how the sunlight would be hitting you early in the morning or late in the evening, sunrise or sunset. Because there's a greater distance of atmosphere for the light to go through than right here, additional scattering occurs. And because of that, the red light is actually able to get through more, the green light kind of gets stuck behind, and so that's why sunrise and sunset is more of a pinker hue because of the scattering. I'm going to give you guys a YouTube video to watch specifically on this question, and they do a much better job of explaining it than I do, okay? But basically we see that the blue light scatters more than the rest, and so that's what we see. And at sunrise and sunset, red and light scatters the most, and so that's what we see, okay? All right, so what is the atmosphere? What's in the atmosphere? Believe it or not, the majority of the gases we breathe are nitrogen. 78%, over 3/4 of what we breathe is nitrogen. We simply inhale it and exhale it because our body doesn't use it at all. We do get nitrogen from some of the food we eat, and our body uses it that way, but we don't use the gas that we inhale at all. Only about 21% of the atmosphere is oxygen, and that's what our body uses. That leaves about a 1% combination of things. Most of that 1% is actually argon. It doesn't really do anything for us either. But it also includes carbon dioxide and water vapor. Water vapor is the gas form of water. And that can change depending on the location you're at, depending on the humidity. That can change kind of where you are, but collectively, there's water vapor all through the atmosphere. Now, that's just the gases. There's also solid particles in the atmosphere. There's things like dust, smoke, little salt particles from the ocean, and chemicals from pollution. And when we get to the chapter where we talk about clouds, we're going to learn why those particles are actually kind of important. You don't want too much of them because that's pollution. So, speaking of pollution, we talked about pollutants when we talked about water pollution. Remember, pollutants are just any of the substances that can cause harm. Specifically, we're talking about air pollution now. And we have natural sources and human sources, okay? There's a lot of natural sources. Soil erosion creates dust. It can cause a lot of additional particles, forest fires, smoke. Oceans, the waves crashing release salt spray into the atmosphere. There's nothing we can really do about that, and it's not necessarily a bad thing, okay? Volcanoes, when they erupt, they can actually cause a lot of problems. A volcano can erupt on one continent, and the ash will actually go if it's big enough, it could actually go all the way around the planet within the atmosphere, okay? And then pollen. It's kind of allergy season right now, so there's a lot of pollen out in the air, okay? It kind of is what it is. But the human sources are cars, industrial factories, farming and construction. Those are all things that we need to be careful with, okay? But most of the air pollution actually comes from us burning fossil fuels. Anything that uses gas or oil or coal, those are all fossil fuels, and they release quite a bit of pollution into the environment. So this picture I have here is kind of interesting. It's kind of timely. This first one, this picture right here, is a picture of France, and this is just demonstrating the air pollution in March of 2019. This one is March of 2020, okay? Well, coronavirus is happening, COVID-19, and people are not going out. People are being restricted. We're being told to stay home. I guess the silver lining, one of the positives that's coming from that is it's actually visibly decreasing the amount of air pollution there is, okay? And there's all kinds of maps like this that you guys can find online. All right, so the air pollution can actually cause a lot of problems with the actual air quality, okay? Smog actually comes from the mixture of smoke and fog, and that's kind of the old-fashioned smog. This is what was occurring over London in the Industrial Revolution, and all these factories were burning smoke and exhaust, and it's a very foggy environment, and so they came up with the word smog. Okay. We still have smog today, but we refer to it as photochemical smog. And that's actually the chemicals that are in the air, the pollution, some of the pollutants, are actually chemically reacting with the sunlight, and they turn brown. Okay. And so you can see this nasty picture down here. The sun's kind of glowing off in the distance. That's a very smoggy, poor air quality day. Another thing that can happen is those chemical particles in the atmosphere can chemically react to water. So when it rains, the water can mix with those chemicals, and they actually form acids, nitric acid and sulfuric acid. They're not going to burn you if it hits you. They're not that strong. But over time, you can see in this statue up there that's on an old building, the acid rain actually starts to etch away some of the statue, some of the stone, and there's also a lot of pictures of that online. So because of this, the EPA, the Environmental Protection Agency, has lots of regulations for us. We have to get smog checks. Factories need to be very aware of what they're putting out into the environment. People are encouraged to buy hybrid vehicles. There's actually government like rebates for that and incentives to do that. I'll tell you what, when I was a kid, this is what the sky looked like all the time. When I was in school, when I was about you guys' age, long time ago, we actually had a device in our classroom, and it told us what the air quality was. And if the smog was too much, we couldn't actually go out for recess. And I remember there'd be days I'd get home and my chest would hurt because it was so smoggy and I was breathing that stuff in. But you guys go outside. I mean, right now it's absolutely beautiful outside. It's very rare for us to get a day that looks like that anymore. And while I think smog checks are difficult and frustrating at times, I'm thankful for them because it's made a huge improvement on our air quality, and it's nice to breathe fresh air. Okay. All right, that's it for sections 1 and 2. Have a great day.